We know that if we start with a composite function f of g of x where there's an outside function f and an inside function g, when you take the derivative, you'll take the derivative of the outside function, so you get f prime, leave your inside function alone, g of x, then multiply by the derivative of the inside function, so it'll be times g prime of x. Imagine that you actually started with that and you had to work backwards. What we're going to do is actually do that with a process called u-Substitution. So we're going to take out something hard, work the problem in an easier version, and then put the hard thing back in. So we're substituting. So it could look like this. We have an outside function that's actually a derivative. So f prime of some inside function, and then you'll see the derivative of that inside function in the problem somewhere. For us, this is going to be the u. We're going to identify the inside function as our u, and then the derivative of it would be u prime. Okay, now when we do this, we know that u prime is actually equal to du, and in this case, since it's with respect to x, dx. Well, when we substitute, we're going to take all of our x's out, and we need to put u's in. So you actually have to take this dx out as well. So what I'm going to do is say that our du, we're going to solve for a du to replace, will be equal to u prime times the dx. Now keep in mind, u prime will be written in terms of x's as well. So we're going to do a full substitution. Now, one other way to see this is you might see, oh, the integral of f of g of x times g prime of x dx. Okay, and it looks a little interesting. And the way they would actually write what this equal to is they'll say, well, let big capital F be the antiderivative of little f, and you'll have your g of x inside of that, plus c. That's the same thing as if we started with an f prime and this landed with an f, so it doesn't really matter. But our steps are going to be to identify u. Then what we're going to do is the same thing we do in the chain rule. We're going to write u prime. Well, we're going to figure out what u prime is, but we're going to say du equals our u prime dx. And then we are going to substitute everything. So no x's, all u's. So we're going to see this in several problems. The first problem is the integral of negative 9x to the third over the quantity 3x to the fourth plus 5 to the fifth dx. So step one, identify u. I'm going to look inside my parentheses. It's right here. And if you ever think you've identified u and it doesn't work, go back and pick a different u. So I'm going to say u equals 3x to the fourth plus 5. Well, just to show you what this looks like in a problem, du dx, the derivative of u with respect to x is 12x to the third. The derivative of 5 is 0. But I don't need a du dx. If you look over here, I have this dx sitting here. I'm going to take this dx and move it. So du equals 12x to the third dx. Okay, I'm ready to substitute. So I'm going to do this in multiple steps so you can see everything that's going on. This is equivalent to the integral, and I'm going to find my u. It's right here. My u is to the negative fifth power. It's to the fifth power underneath the fraction bar. And I still have a negative 9x to the third dx. But the idea of u-Substitution is I take out all the x's and I put in u's. I'm halfway there. So my next step, I go over here to this du, and I compare the two. Now the x to the third dx is the same, but this is a negative 9 and this is a 12. Well, this is my problem. This is what I want, so I'm going to change this 12x to the third to a negative 9x to the third. And it's very simple. To get rid of the 12, I divide by 12 on both sides. And to get a negative 9 on, I can very simply multiply by a negative 9. So if I reduce this fraction, negative 3/4 du equals a negative 9x to the third dx. And I have a substitution. This piece right here, all of that, is a negative 3/4 du. So I'm going to rewrite this one more time before I integrate. I'm going to bring the number to the front, then my u piece, and then the du at the very end. And this is what I'm integrating. When you integrate, I'm going to bring the negative 3/4 straight down. Now I'm going to raise the power by 1. So u to the, and it will now be negative 4th, divide by my new power, which is the same as multiplying by the reciprocal, plus c. When I multiply straight across, this becomes a 3/16. U is 3x to the 4th plus 5 to the negative 4 plus c. I'm going to rewrite it one final time, taking care of the negative exponent. So 3 is in my numerator, 16 is in my denominator. My u will be in the denominator, to the 4th power plus c. And that is the integral. For this next problem, you have two sets of parentheses, so that confuses some people, but if you'll notice, it's the same thing in each. So I'm going to choose my u as 3 theta. So my du, and this would normally be a du d theta, but I'm going to take the derivative. It's a 3. I'm moving my d theta to the right. So I'm ready. This is the integral. And I'm going to write my u piece first. You can't separate the u from the trig function, so it's secant u, tangent u, and I still have a 7 and a d theta. To fix the 7 d theta, I'm going to come to my du. You can see it's close. I have a 3d theta, so I need to turn this 3d theta into a 7d theta. So I'm going to divide by 3 and multiply by 7. So 7/3 du equals 7 d theta. So this is 7/3 du. I'm going to write it one more time. The number goes to the front, then my u piece, then my du. Well, I know I can bring the number straight down. The coefficient comes down. It could actually go outside of the integral because it's just multiplied. Then the integral of secant u tangent u is just secant u plus c. And my u is 3 theta plus c, and that is finished. For this next problem, people have an issue deciding which is my u. There's two things that tell you. This one has the higher power inside. You want to actually choose that because the derivative will have a lower power, and this has to be the derivative if this is the higher one. If you choose this, you're not going to have this problem solved. The second thing is that this is to the 3rd power, so this could be a u cubed in there. This is just the first, which doesn't explain any of this. So I'm going to choose my u as x squared minus 2x. So my du would be a 2x minus 2 du. I come back over to this function. I'm going to write my u piece first. Here's my u. It's being cubed. And then everything else is a 4x minus 4 dx. Now you look at your du piece and you can see the relationship. This is 2x minus 2, this is 4x minus 4. There's an easy fix. I can multiply both sides by 2. So 2 du equals 4x minus 4. This should be a dx out here. Dx. So this piece is very simply a 2 du. I rewrite it one more time. I'm going to put the number, the coefficient up front, then my u piece, then my du. And I'm ready to integrate. Bring the 2 down. It becomes u to the 4th power. I'm adding 1 to the exponent. Multiply by the reciprocal, 1/4, plus c. This is 2/4 or 1/2. My u is x squared minus 2x to the 4th plus c, and that is the integral. Now you notice I went from example 1 to example 3 to example 4. I'm going to show you example 2 on the next video, the second example from the notes, but it's more complicated, so I'm just choosing for the videos to do it out of order because it will take a little bit longer.